Okay, we were talking about model selection and impact of misspecifying models. So actually we haven't gotten to model selection yet. We're only talking about the impact of misspecifying models. And we were only considering the instance of misspecification where we've either unnecessarily included or unnecessarily excluded the x2 variables from this model. So we had just worked on the instance where we have unnecessarily excluded the x2 variables. In other words, we have underfit the model. Now let's talk about the instance here where we fit model 2, but model 1 is true. We've actually overfit the model. Now let's first discuss the idea of bias. Okay, so I think I can argue with no mathematics that our beta 1 hat expected value under model 1, where beta 1 hat was fit under model 2, should just be beta 1, and that the expected value of our n minus p now, s squared, our residual variance estimate, okay, is just sigma squared, n times n minus p, where p is the total number of parameters, p1 plus p2. I think I can argue, so in other words, both the bias that we saw in our coefficient and the bias that we saw in our variance estimate both go away if we fit model 2 but model 1 is true. Now why is that? And why don't I need any mathematics? Well, because we've already shown that our residual variance estimate is unbiased and our slope estimates are unbiased if in fact we fit the correct model. In this case, we have fit the correct model. Model 1 is exactly a special case of model 2 in the instance where beta 2 equals 0. So if we fit model 2, we have fit a model that contains model 1 as a special case. And therefore we have fit the correct model. And so our estimates are going to be unbiased. Okay? So this might seem counterintuitive, but I think the argument is fairly clear. So we could go through the calculations, but they're just the same calculations we've always gone through to show that estimates are unbiased and that our residual variance estimate is unbiased. But now that raises the question, well, what are the consequences of overfitting the model if in fact we get unbiased estimates? Well, first, you can't just keep throwing variables in because at some point you'll get an overdetermined X matrix and you can't even invert it. So there is that problem. So we're still also assuming whatever variables we included unnecessarily by including X2 don't render our design matrix non-invertible. Okay, so we're all, at first we're assuming that. But there's going to be some consequences, and that's what we're going to get to in the next video, of including variables unnecessarily. But one of the consequences is not bias, because as we see right here, we get rid of the bias by including all the necessary variables and then even some extraneous variables. That bias then goes away. Okay, so now let's talk about the consequences. Basically, all the consequences are going to be related to variability, our estimates of variability.